Okay, so this is our last section of the chapter. As a reminder, our test is Thursday, Friday. It's a 2-day test where Thursday's the non-calculator portion, Friday's the calculator portion. We will have 2 days of review. Okay, so tomorrow we'll do an activity and you'll get your review worksheet. Okay, on Friday we already talked about tangent graphs. Those and then all of the secant and cosecant graphs clumped together for one homework assignment that I'm going to check tomorrow. I will also have my worked out key online for you to check with this evening if you won't get your graph. Okay? But let's talk about what we know about secant and cosecant. What do we know about secant? Okay, it is something of cosine, but I'm going to have you change your word for not opposite, but reciprocal. Okay, it is the reciprocal. Inverse cosine is the inverse of cosine. Okay, but the secant is the reciprocal of cosine, and we know that the cosecant is the reciprocal of sine. Okay, now if I have a number like 2/3, what is the reciprocal? Okay, what'd you do to get 3/2, Jacob? You flip it, okay? So when we're talking about a reciprocal, in our minds we think, we have to flip something, right? Well, that is exactly what we're going to do to get our graphs. We're going to take our sine and cosine functions, and we're going to take those y values and we're going to flip them in order to make our secant and cosecant graphs. Now, it does happen where the sine and the cosine end up being 0 in some places. What happens when you take the reciprocal of 0? We get an undefined value. Okay, so that's going to happen a couple times, and we'll have to deal with that when we get there. Okay, so what I'm going to do is we're going to take the sine and cosine parent graphs, and we're going to flip them to make them the reciprocal functions, and then we'll talk about how to graph them from there. Okay, so let's start out with, I don't even remember which one, y equals the sine of x. Okay. And we're going to take our graph of y equals sine of x, and we are going to make it y equals cosecant of x. Okay, so go ahead very lightly sketch in the parent graph of sine so that we can do this together. And I just have one period up here, because that's really all I care about for graphing. Now, we just talked about the reciprocal of 0. You told me that the reciprocal of 0 is undefined. Think back to when we did on Friday. Graphically, what do we have to place when we have an undefined value? We have a vertical asymptote. So these 3 places where the sine is 0, the reciprocal would be undefined. So our cosecant graph is going to have an asymptote, a vertical asymptote at x equals 2 pi, x equals pi, and x equals 0, because those are the places where sine is 0, so our cosecant would be undefined. Hey, and we have vertical asymptotes, so much like on Friday, I am not going to ask you for the domain of these graphs. Okay, that would not be a very fun thing to notate. It's not worth our time to figure out how to do that. So we just know that the domain is broken up by those asymptotes. Okay, every half of a period. Okay. Now let's start reciprocating the curve in between. Okay, we'll start with an easy one. The sine of pi over 2, the sine of pi over 2 is 1. What's the reciprocal of 1? 1. So this point actually stays the same, but then when we look at, like, the reciprocal of 1/2 is 2. The reciprocal of 1/2 is 2, and the reciprocal of 1 over 16 is 16, and the reciprocal of 2/3 is 3/2. What happens is we get this U shape. I don't really like the way that looks. Where these U's go on forever as we approach the asymptotes. Okay? And same thing's going to happen down here. The reciprocal of -1 is -1. But then when we take all of these numbers between 0 and -1 and we make them reciprocals, we get numbers really negative. And we're going to get this U that approaches the asymptote. Okay? So now imagine that sine graph not being there. The blue and the red that I have up here, that is your cosecant curve. Okay. Since it is the reciprocal of sine, we can think about how we would graph sine and then use these 3 places for our asymptotes. And then from our high and low point, we can create our U's in between. Now, I will ask you to describe the range, so let's just go ahead and practice with the parent function. If I were to ask you to describe the range of this parent function right here, Emma, what would you describe the range for the blue curve? Well, that would be the domain. If we look at the y values for the range, where do we have y values? Yep, that's exactly it. We have values from 1 and above and from -1 and below. So we would describe this as -1, infinity to -1, and 1 to infinity. And since we have coordinates at 1 and -1, we can put brackets around there. Okay? So it's basically taking our sine range and just like flipping it out. Right? All right, should we look at a secant graph? In order to construct the parent function for secant, I'm going to ask that you lightly draw the cosine parent function. And then we'll base our secant graph off of the cosine parent function. So just like we did with our sine graph, we know that the reciprocal of 0 is undefined. So these places where cosine is 0, here at 3 pi over 2 and pi over 2, we are going to have asymptotes for our secant curve because that's where the cosine is 0. So we have asymptotes at x equals 3 pi over 2 and x equals pi over 2. And then the same thing is going to happen. Wherever we have our high and low points, we are going to put a coordinate shared with cosine, but then we're going to have u's that approach the asymptotes. Okay? So technically for one period of our secant curve, this is what it would look like. If it bothers you to draw half of a u and you want to finish these out, I don't have a problem with that. Technically, this is one period, but if you need to finish these u's up top, that's fine. I know that bothers some people, so you do what you need to do. Here again, really, the red asymptotes and the blue curves, that's what the secant graph is. We can ignore the cosine curve, we're just using it as a base. Okay, so when we talk about the range of this parent function, we have the same thing happening. We have values, below and including -1, and we have values above and including +1. So as we have vertical stretches and vertical shifts, that will affect our range. As we have horizontal shrinks and stretches, that will affect the period. What's nice about graphing these is we identify everything just like we would a sine or cosine curve. We're basically going to graph the sine or cosine curve and then draw in our u's and asymptotes based on that sine or cosine graph. Okay? Now, is this a graph that has amplitude? If you look at the blue, does this graph have amplitude? Is it bouncing between two values? Nope. Sine and cosine are our only two curves with amplitude. Okay, so keep that in mind. We are going to do two graphs. What I'd like you to do is write down this graph and at your table, identify together A, the period, and the starting point, and then stop. Write it down, identify A, period, and starting point. Make sure you all agree upon it, and then stop. We'll graph it together. Okay, so the absolute value of A is 2. That's going to help us draw our frame, but we cannot call it the amplitude. Okay? Caden, what did you identify for the period?
2 pi.
Okay, remember we are back to 2 pi divided by B. And B is 1, so Caden's got 2 pi for his period. Okay? And then the starting point. Madeline, what do you have for your starting point? Pi negative 2? Why are you changing it to negative pi? Okay, we're a shift to the left because it's x plus pi, so that our starting point is at negative pi negative 2. Okay, so now we're going to build a frame just like we would for what kind of reciprocal curve? A sine. Okay, we are going to build a sine curve based on this information. So our starting point is negative pi negative 2. Since a is 2, absolute value of a is 2, we're going to go up 2 to 0 and down 2 to negative 4. Okay. Negative pi is where we're beginning with our x value, and our period is 2 pi. Okay. So if we add 2 pi to where we begin, then where would we end? 1 pi. Okay? This is where some of you are having some trouble. Just because my period is 2 pi doesn't mean I put that number there. We have to add it to whatever this is if you're using the midpoint method. Okay? So then halfway between negative pi and positive pi is 0. And then halfway between those would be negative pi over 2 and positive pi over 2. So we're constructing our graph, our frame the same way we would. We're labeling it the same way we would. Okay, I'm even going to go as far as I'm going to with my green. Remember, green means light. I'm going to just lightly draw in my negative sine curve so that I know where to place everything. So cosecant the reciprocal of sine, and we have a negative a value. So I know that these are our 5 coordinates. Okay. Now that we have our sine curve, we can go in and draw our asymptotes and then our u's. Okay? So our asymptotes are going to occur every time we hit that middle of the frame because it's been shifted from that x-axis. Okay? So we have an asymptote at x equals negative pi, x equals 0, and x equals pi. We then have 2 u's, and I want you to label these points. So you're still labeling 5 items, it's just not 5 points. There's either 2 or 3 asymptotes and either 2 or 3 coordinates depending on which graph we're doing. Okay, so we have this u opening down, okay, to match with our curve. So this is at negative pi over 2, negative 4. And then we have this u up here at pi over 2, comma 0. You would not have to draw the sine curve really, really lightly if you can visualize what's happening, okay? But it does not bother me for you to draw it in very lightly and then just make sure that your asymptotes and your u's are just a little bit darker because that's the curve. That's what I want to stick out. Questions on this graph? Does it really feel like we learned anything new? I mean, it's kind of like you just added one more step to our sine curve, right? Okay. One more thing to think about before we do our last example is the range. The range describes where the y values are. Ryan, what would the range be for this graph? Good. That's definitely good. Negative infinity to negative 4, and then 0 to infinity. You're basically going to take the bottom and top of your frame, and those are the y values you need for your range. Okay? It stops at negative 4 and then picks back up at 0. All right, one more graph, and then this is the last example that we'll do all week. Okay? Tomorrow and Wednesday are just review days. So here we go. Last example. Write it down and identify for me a period and starting point. I love how Pod 1 is comparing your answers. Thank you. All right, our A value is 1. The period. Jack, what do we get for the period? Pi. 2 pi divided by b, 2 pi divided by 2, we get a period of pi. Okay. This one's a little bit more exciting, isn't it? Okay. Our starting point. Gracie, what's the x coordinate for our starting point? What? Negative pi. And how did you get that? So C divided by B negative pi over 4. Because when we divide by 2, that's like multiplying by 1/2, right? Okay, I like that, pi over 4. And then our y coordinate would be what, Kelly? 2. Great. Okay, so really lightly, we'll create our cosine frame, draw on our cosine curve, and then we can go from there. So negative pi over 4 comma 2. Our frame is going to go up 1 to 3 and down 1 to 1. Oh, that's terrible. We're going to go for it. Okay. If our period is pi and we're beginning at negative pi over 4, when we add pi, where would we end up? 3 pi over 4. If you're at a fourth of the period every time kind of person, then a fourth of the period is pi over 4. So when we begin here and add pi over 4, we would get to 0. And then we would add pi over 4 to get to pi over 4. And then we would add pi over 4 to get to pi over 2. And then add pi over 4 to get to 3 pi over 4. If you're that kind of person, there's that method. All right? Secant is the reciprocal of cosine. Now, here is something that bothered me on your quiz. So please, everyone, eyes up here so you can hear it. Our starting point is always in the center of the left edge of our frame. Our cosine does not begin at the starting point. Here is the starting point, but the cosine curve begins in the corner above it. Okay? Some of you are constructing your frame so that your starting point was where your cosine graph started, but that's not the case. All right? Okay, so here is what the cosine curve would look like. We go to where the parent graph crossed the x-axis, and that's where we put in our asymptotes. And then draw in your U's based on where these coordinates are up here. What's nice about this section is you get to practice sine and cosine curves again and just go another step further. If you are having trouble on your quiz with a specific part of graphing sine or cosine curves, and you're still struggling with that after our notes today, come and ask me a question, okay? I'm here after school, I'm here before school. I have second Titan time. I have 6th and 7th period where sometimes I can be available depending on the day. Sometimes I have meetings, sometimes I'm just in that office next door the whole time, those 2 periods. So communicate with me. If you have something that you're not quite understanding, we gotta get it figured out before Thursday, okay? I would love for you to just ace all of these graphs, okay? So you have a homework assignment. You may have already started it if you did the tangent graphs over the weekend.